Our project is entitled Novel Way of Energy Sharing and Selling. Electricity is scarce nowadays, and we should focus on ways to use and store the resource very carefully with minimum loss. Our project focuses on maximizing the ways to harvest the alternative energy in every household and thereby sharing and selling the power in times of need to other households or to the substation. This will optimally make use of the power generated from the alternative energy even when the occupants of the household are away from their house. The system can attract people to invest in installing alternative energy sources since it will fetch them an income if it is shared or sold to others. These are the TI components we have used in our project. Overall block diagram of a project which encompasses all the features included in it. There is a household and a substation with power line communication in between them. The substation can be controlled remotely and it monitors the whole system with the front-end software, and the user can access details using Android application. Every household will have an alternative energy source. It can be solar, micro, or wind power. Microinverters employed to gain the maximum output. Relays in the household will be controlled by the MSP430 launchpad to direct the current to the transmission line or to the household along with the data which employs power line communication. Household makes use of alternative energy and grid energy. The power consumption is calculated by the smart digital energy meter which sends information over the power line to the substation for billing purpose using a front-end software. Conventional three-phase line distributes power from the substation. Substation has remote connectivity. Any other system can take control of substation over the internet. Customers having Android devices can view their bills and other relevant power details in a user-friendly application. The substation carries out automatic billing, monitors illegal tap detection, monitors power collection and sharing, and monitors the transmission line. In this animation, we can see a household or a firm, as we take it, where power is generated from the solar panel or a windmill or from the footsteps of a person on a special arrangement creating micropower as shown by the green circle. The windmill in a household may produce DC using DC generator as it's a small installment. All these power are fed to the inverter to obtain alternating current and is stepped up by a transformer to be distributed to the transmission line towards the substation. This is a substation where the sold power by the customer from the transmission line is stepped down as shown by the green circles. The energy is stored and then redistributed to the other households when needed as shown by the orange circles. The power in the shared line from the household is stepped down in the substation. The alternating current is then inverted to direct current for storage in battery. The stored energy can be used later for household or other purpose. We have set up two households and a substation. Each household has got a solar panel, a control panel consisting of a controller switch, relay, MSP430 launchpad which controls the system, encoder circuit for power line communication, and a LCD. The LCD displays the relevant power details processed by the MSP430 launchpad. This is the smart digital energy meter which measures the energy and which is sent to the launchpad for further processing. The substation consists of a relay, a filter circuit to reduce the noise, a decoder circuit, an Arduino board which acts as a data acquisition device, a transformer, and a battery to store the energy. This is the front-end software monitoring the whole system and is designed with LabVIEW. The solar panel here is continuously charging a battery. This is a battery charger with cutoff circuit, and this is the inverter circuit which is converting direct current into alternating current. Two LDRs to align the solar panel in the required direction perpendicular to the sun ray. Now as the sun ray falls on this LDR, the panel automatically aligns in that particular direction. After some time, when the sun ray falls on this LDR, the panel automatically aligns its position according to the ray. The battery level is sufficient is indicated by the LED. Whenever the battery level falls down, here we are using an uncharged battery, automatically the buzzer will start beeping. The battery's DC is then inverted using the inverter circuit and the stepped up voltage is obtained finally, which is shared to the transmission line or used in the household. Relays are used to switch the alternating current either to the household or to the transmission line. The power consumed and the total time of power consumption is displayed in this LCD. Here, in this case, one bulb is on and the power consumed by one bulb is displayed here as 15 watts. When the other bulb is switched on, the total power consumed by both the bulbs is displayed as 30 watts in the LCD. If the power generated in the household is in excess after consumption, automatically it will be transmitted over the transmission line to the substation. The switching of the relay between the household and the transmission line can be automatic or manual. Most of the times it is automatic. It can be made manual when the occupants of the household are away from the house and the whole power can be fed to the transmission line using this switch. We have employed power line communication where the data about the power consumed, power sold and the time are sent over the power line to the substation for billing purpose. The information from the microcontroller in binary form is encoded by this encoder circuit and the encoded information is finally coupled by the coupling transformer to the transmission line for transmission to the base station. This is the setup for transmitting encoded information. The information can be used for billing purpose. The data from the household is converted to binary form by the microcontroller. The switches denote the address of the household. The address along with data are encoded by pulse width modulation. The decoder performs the inverse in the substation. For instance, if a house is consuming 8 watts, it is converted to binary form 100 by the microcontroller and is appended to the address. This is encoded and sent to the substation. The 8 watts in binary form is shown by the LEDs, which is 100. This is the waveform of the encoded data. The first 8 pulses denote the address and the last 4 pulses denote the data. The ones in the data have small width compared to the zeros. We have designed a user-friendly Android application for the customers having Android devices. Using this application, the billing details, alternative power characteristics, and the details regarding power consumed and shared are notified to the user. In the billing section, the consumed power, shared power, power rate are shown. The alternative power characteristics plots the graph. Here the statistics of the power consumed and shared is shown. The transmission lines here are a neutral line, a live line and a shared live line, which is used to share power between the substation and the households. The power from the shared line after inverting can be stored in the battery in the substation. The stored energy in the battery can be inverted and used to power households. The data from the shared line is filtered to remove noise and is decoded and is given to the Arduino board, which is sent to LabVIEW for processing. We have developed a GUI by which we can access the front end of the substation from any other computer. In this, we can see all the details such as the grid power being shared, the grid power being saved, and the customer billing details. This is the front-end software designed with LabVIEW. This tab shows shared power of grid or alternative energy. Here the graph is plotted for the grid power, shared power, and the stored energy. This tab shows the customer billing details such as used power, shared power, power rate, and the balance amount.